Welcome to qnawire.
Factorize fully 8y to the fourth power n squared plus 162 z to the fourth power n squared. To begin, we will consider whether the two terms in the given polynomial have a highest common factor, or HCF, which may contain variables, constants, or products of variables and constants. We determine that 2n squared is the highest common factor of the two terms. By dividing each term by the HCF, we find the remaining terms in the parentheses to be 4y to the fourth power plus 81z to the fourth power. We notice that the polynomial in the parentheses contains two perfect square terms, so we will attempt to factor this expression by completing the square. To use this method, we will need to manipulate the expression in the parentheses to include a perfect square trinomial in the form a squared plus or minus 2ab plus b squared, which can be factored as a plus or minus b squared. In these trinomials, a and b may be variables, constants, or products of variables and constants. In this example, if we take a squared to be 4y to the fourth power and b squared to be 81z to the fourth power, then our value of a is the square root of a squared, which is equal to 2y squared. And our value of b is the square root of b squared, which is equal to 9z squared. Then our middle term is equal to 2ab, or in some cases, negative 2ab. 2ab comes out to 2 times 2y squared times 9z squared, which is 36y squared z squared. In our next step, we will introduce the 2ab term into the original expression. For any term we introduce into the expression, we must add the same term with the opposite sign. This way, we are effectively adding 0, which does not change the polynomial. In this case, the 0 gets added to the polynomial in the form of 36y squared z squared minus 36y squared z squared. Our expression with these new terms is 2n squared times 4y to the fourth power plus 36y squared z squared plus 81z to the fourth power minus 36y squared z squared. We can now factor the first three terms in the parentheses as a perfect square trinomial, giving us 2y squared plus 9z squared squared. Now we have a difference of squares, since the expression within the parentheses is being squared, and 36y squared z squared is a perfect square. Specifically, the square of 6yz, where a is in the first parentheses and b is in the second parentheses. Following the formula for factoring a difference of squares, we get 2y squared plus 9z squared minus 6yz times 2y squared plus 9z squared plus 6yz. Finally, we need to check whether the resulting polynomials within each set of parentheses can be factored. In this case, both polynomials are prime. So, we have that 2n squared times 2y squared minus 6yz plus 9z squared times 2y squared plus 6yz plus 9z squared represents the full factorization of 8y to the fourth power n squared plus 162 z to the fourth power n squared.